Or- Hello, hello. Good morning, evening, afternoon, wherever you are. Apologize for kind of the delay in this recap video, as it was the Thanksgiving holiday here in the United States. But yeah, wanted to quickly just review week eight, kind of what we covered in the live session. If you didn't attend that or haven't watched the recording yet, highly recommend that you do, as well as introduce the capstone and a couple of gotchas that we've already kind of seen going into week nine. And yeah, week 10, almost done here, 2 more weeks. So yeah, week eight, this was more intermediate slash advanced machine learning topics. We dove deep into random forests and tree-based algorithms, starting with decision trees. We covered what is a decision tree and how it's used, as well as some of the limitations that you may run into with tree-based algorithms. Again, friendly reminder, we talked about three different families of algorithms. The first being linear models, which are going to be mathematically sound, defined by equations. Think of your linear regression, your logistic regression. The second family is tree-based models, which are going to be rooted in decision trees. And then your third family that we spoke about was neural networks. So with tree-based models, we talked about how a single decision tree is typically prone to overfit, and we can account for that by having multiple trees in a forest where each tree is trained on a random subsample of the data. We can even boost trees in that forest, which gives us the kind of best algorithms that we have based on this tree-based model, including XGBoost, LightGBM, and CatBoost. Note that these tree-based algorithms can capture non-linear effects as well as are not bound by the assumptions that typical linear models have to be bound by, such as multicollinearity, right? Uh, cool. We also dove into model evaluation. So we had a big focus this time on model evaluation for classification problems. So last week in week seven, we went deep into mean squared error, R squared, MAE, all that good stuff. With week eight and classification models, we dove into your type one and type two errors, classification report, precision, recall, F1 score, and we even talked about rock curves and the area under curve metric. So given that we now know how to train multiple algorithms from multiple different families, such as linear and trees, and we know how to evaluate regression and classification problems, we then talked about the final step in the tuning and more formal, like I guess, machine learning systems. Now we spoke about cross-validation and why that's important, eliminate the train test split and the kind of luck that can come into the randomness associated with it. Hyperparameter tuning, how do we tune all the different parameters, such as how many trees do we need in our forest, and looking at feature importances for tree-based models. We put all this together in a pipeline. Yes, that is a scikit-learn pipeline, but also from start to finish. We did an example where we tried to predict if it was going to rain tomorrow, given some weather characteristics today in Australia. So we imputed missing values, we created new features, we did our encoding of categorical features as well as scaled numeric filter features, built a full scikit-learn pipeline for pre-processing to remove any of those pitfalls. We evaluated multiple algorithms across different families, such as logistic regression, random forest, and XGBoost, and we evaluated our models using type 1, type 2 errors, as well as precision and recall, and talked about class imbalance. Also included in Module 8, but was not really covered in the live session, was unsupervised learning, including clustering such as k-means and db-scan, as well as principal component analysis for dimensionality reduction. You won't need either for the capstone, which is why I did not go into depth with them for week 8. Let's see. Quote of the day, all models are wrong, but some are useful. I'm pretty pessimistic when it comes to models and AI and things like that. So just note that every model has bias and limitations, and it's up to you to know how can this model be actually effective in driving decision making at your organization, aka how is this model useful? In summary, we're to focus going into from week 8 into week 9. Yeah, there's like 15 week 8 notebooks, so I do recommend going through all of them and going slow. But note that kind of see how we're building through week 8, right? We start talking about decision trees and then random forests, and then we dive into classification models, give a high review of unsupervised, and then run into the, I guess, final project for week 8, this Australia rain predictor. Let's see. Try adding grid search and cross-validation to other models you may be building. It's pretty copy-paste code from kind of what you saw in class. And don't forget to model explainability. For extra credit, we linked a couple of the Kaggle learns. I'm also just going to add in one more here. Let's see. Yeah, the intermediate machine learning lines up basically uh, eye to eye with the week 8 here. But if you wanted to look at another one, the machine learning explainability is actually really interesting. So we don't go into too much depth of these topics over the next couple of weeks, but definitely recommend kind of looking at like Shapley values and things like that to help explain your model beyond just feature importance. Let's see. All the code for week 8 is in GitHub already. And if you want to look at what we covered in the live session, like I said, we talked about decision trees as well as random forest and XGBoost, and then our final project here on Australia weather. Now, if you watch the live session, I think my kernel died like near the end, so I couldn't get the XGBoost to work, but I finished that after class. So if you scroll down far enough down here, yeah, try another model, and we should be able to see that we're doing the logistic regression here, and then yeah, there we go. I did the XGBoost one as well. So again, we did encode the targets. That's our Y values because XGBoost expects it to be a 0, 1. We in our grid pipeline, we use the XGBoost classifier. We actually set the pipeline like way back up here and then just overwrote the model each time. But let me see if I can find the definition. Yeah, we have our preprocessor and then whatever our model is. And for the preprocessor, we just have our scaler as well as our encoder. Yeah, our one hot encoder. Easy peasy. So again, a lot of this is like copy paste, right? And then you'll see we did a grid search for our hyperparameter tuning, and then we evaluated the model. And we can see that I think it was actually a little bit less. I think it wasn't like as good as the random forest. Let me see. 197. I'm looking at my recall, my true positive. So 197 is the value I'm going to go off of. That's also this 55% recall, which is not great. A little over 50% of the time, we're able to predict if it's going to rain tomorrow or not. But going off of this 55 number, we can quickly compare that against, yeah, better than the logistic regression, which is good. And it is also better than the random forest. So go us. My XGBoost model was the best algorithm here, even though it still wasn't that good. And looking at the feature importances, you can see that this kind of makes sense. The humidity and pressure, and then the season and the amount of sunshine and the wind were all kind of fairly important. This is humidity today at 3 p.m., which is the latest observation we had in the day. It kind of makes sense that the current humidity and pressure today will impact whether it's going to rain tomorrow or not. So anyway, that's week 8, more advanced modeling topics. So you should have a pretty strong grip of regression and classification, as well as with linear and tree-based models. In week 9 and 10, we're going to start putting all of this together into a capstone study on SpaceX, which I actually have over here. So how the capstone's going to work, you'll see for week 9, I think it's 5 notebooks. One, two, three, four, five, but they all kind of build on each other and are all going to be, I guess, submitted as part of your overall capstone project. So for the capstone, what we're going to be doing here is we're going to try and predict to determine I think it's a classification model we're going to be building. We're going to determine whether or not this first stage from a SpaceX rocket will land. And again, we're going to be predicting the probability of a successful landing. So again, that'll be a classification model. But the first few steps in module 9 are all data engineering. We'll do the model building in week 10. So in week 9, we're going to be acquiring data both from the official SpaceX API, which is pretty fun that this is actually like a real live API that we can just hit. I've built some pretty cool apps of this in some spare time that I've done. But anyway, it's pretty cool. We're going to be using the SpaceX API, and then we're also going to be doing some web scraping against the SpaceX Wikipedia pages. Let's see what else. I think the next things we're going to do is, yeah, just some exploratory data analysis of our data. We're going to do some rudimentary data cleaning and feature engineering, and hopefully get some data that'll be ready for processing as a model in module 10. So that'll be kind of the ideas here. Some students have already gotten started on the notebooks. And there's only 5 notebooks, but they're all pretty long, and there's no hints or anything. As like again, this is like your capstone project for the course. So if you run into issues, definitely reach out on the forums, like some students are already doing. And I've also gone ahead and set up and run through all the notebooks on my own as well. It did take me a couple of hours to do all 5 notebooks, so it'll probably take you, I don't know, 6 hours. So just keep that in mind as you start working through. I think it's supposed to take 8 hours is what they allocated, but like I said, it'll take you a few hours to go through all the notebooks. So you'll see we have one where we pull data from an API, where we pull data from the web. We do some data wrangling with that data, and then we do some EDA as well as like some queries using SQL and stuff, if you remember that from a few weeks ago as well. So it should be fun. More students are running into issues. The web scraping notebook has a couple of issues, not issues, but it's a couple of bugs to look out for. So first, if you do not include a header, technically you violate the Wikipedia like robot policy, where as a responsible and ethical data scientist, if we're going to be web scraping Wikipedia, we want to make sure that we are adhering to their generally applicable rules. So, long story short, they expect like an identifier, like who are you and why are you scraping our website? So you do need to supply this header that says, "Hey, I'm in the IBM data science course, and this is an educational project." Again, this is probably too much information, but whatever. You have to provide some sort of header here to identify who you are for audibility and accountability, and then everything should work fine. And then the second issue you may run into on the web scraping notebook is down at the bottom here, where you need to append customers. Not all customers have a link or an A tag. Remember, an A tag in HTML is a link. So this code I had to update and change as well. I think in the starter notebook it gave you, it just said to pull the text value from the A tag, but you need to add in a quick conditional here. If the A tag exists, then pull the string from it. Otherwise, just pull the first string. And honestly, off the record, you could just pull the first string and it'll be fine. You don't need to check for an A tag, but whatever. And then everything else I think worked pretty well. It's just a lot of code, and you do need to kind of be hands-on with it and do your own kind of work here. So definitely use AI as needed to help you, but don't use it as a crutch. Use my notebooks here to help you, but also try not to use them as a crutch. Work through them on your own here. As again, these 5 notebooks and some of the associated data sets that you'll create off of them should be all bundled together in your repository for your final capstone project here. Please join us for the live session on Monday, December 1st at 7 p.m. GMT, 2 p.m. Eastern Time, which honestly will probably happen before you see this recap, but whatever. And yeah, long story for the live session, we're going to run through a couple of those notebooks. I'll pick my favorite ones to run through in the hour and a half that we have together. And then, yeah, week 10. Week 10, we'll wrap everything up, build our model, build a couple cool visualizations, throw it all together into a slide deck, and then you're done. Friendly reminder that I grade your capstone submissions, so please make sure to have them all neat and tidy and have Karen and I be able to access them. And again, we'll go into how they're going to be graded more next week in week 10 here. I think the last thing to note is week 9 only also has one discussion post. So please try and participate if you can. It should be fairly straightforward as well. So definitely reach out in the forums if you have any problems. Try and answer. You'll see some examples here. I may put my own thoughts into what this will be in the live session tomorrow as well. I know so I had someone read over this and was like, this is kind of asking for a lot. Like, what's it actually asking for? And I was like, yeah, I'll give you my interpretation of this tomorrow. So look out for that as well. But again, try and mark your own responses here as when you can. Cool. I think that's all I got. So, long story short, week 8 was intermediate machine learning. We went deep into tree-based models, provided a high-level overview of the other kind of algorithm families, including neural networks, as well as the other type of machine learning, unsupervised, including clustering and dimensionality reduction. But again, our focus was mostly on tree-based algorithms as well as classification problems in the supervised branch of machine learning. Week 9, you're going to be starting on your capstone. You're going to be creating 5 notebooks with additional data sets created off of that. That's going to be acquiring raw data from source, cleaning it up, preparing it, writing it out to a SQLite database, and then writing some exploratory data analysis and feature engineering against those data sets. We'll pick that up in week 10, where we're then going to build our models off of that data. And again, our goal is to predict whether or not a SpaceX launch will result in a successful landing. All right, that's all I got. Stay warm, stay safe, have a great weekend, and I will see you all Monday during the live session. Cheers, everybody.